Hello dear students, welcome you all. This is the topic which I covered from this lesson, that is nomenclature of carbon, or you can also be called the configuration of a carbon, which is used generally in stereochemistry. And in this lecture we will first focus on the RS type of what nomenclature, then after that we will see alpha, beta and DL type of what configuration. Okay, so first of all, what is that RS now? So in you know that why we are using these terms RS. Okay, so basically in organic chemistry, what the compounds are what spatially, for example carbon species. Okay, especially we are focused on the carbon, classify or notated in a specific way. Okay, and that's why it's called the R or S. Okay, alpha, beta, D, L, these are the type of one configuration. So that R is nothing but the what rectus, or simply we can call what the right side. Okay, and in case of what we can also be called the proper, right, proper, or you can call the rectus. While in case of what S configuration is there, then it is called what the sinister, malicious, or also be called as a left one. Okay, so we will see first one, what is that RS nomenclature. Now this RS nomenclature is said to be what the CIP rule. Okay, so what is that CIP rule now? It is called the Can, Ingold and Prelog rule. Okay, according to this RS nomenclature, first we will see what is that R and what is that S. So that R is nothing but the rectus. R is nothing but the rectus, which is meaning as proper, or that is nothing but the one right. While the S and we can be denoted R is like this. Suppose this is your R, so here, so we can be like this. Okay, this is R. And in case of what S isomer, or the S type of what configuration, here S is equal to sinister, that is called malicious, and which is meaning as a left. Okay, and if we see actually what is that S now, how this S is look like, here this is the S later, and it can be represented like this. So here like this. Okay, so actually it is a type of what S1. Okay, so this is all about the R and S. Now we will see first upon how one can assign that R and S configuration to particularly the carbon. So what type of carbons are there? So Can, Ingold and P Prelog rule, that's called the CIP rule. So carbon should be asymmetric. This is the first condition. So there should be a asymmetric carbon. You know that what is asymmetric? The carbon should be attached with 4 different substituents. They are covalently linked with the 4 different substituents. Okay, like this. So this is the carbon, actually tetrahedral carbon. So according to want label, so first tetrahedral carbon is a non-planar, and you know that, so carbons consist of 4 bonds. Out of the 4 bonds, 2 bonds are in a plane, which are indicated in a white line. So these 2 bonds are in a plane. Okay, and this is yellow colored. Okay, so is nothing but the atom or group which are present below the plane or away from the observer, while the red color which is mentioned in the thick line, so that is called what the bond or group which are present above the plane or nearer to observer. If you have an observer, so observer means near to observer, or this is will be away from the observer. Okay, now so this is the chiral carbon, actually A, B, C, D, these are the 4 different substituents. Okay, in which what, so D is an away and C is above the plane. Now what are the points should be noted? So during this RS configuration, first is a select the chiral carbon in a given molecule. If chiral carbon is there, so then first look at the molecule, identify the chiral carbon, assign the priority, assign the one priority according to its atomic number. We are just, you know that 4 different carbons, 4 different substituents are there, and you can give the priority, you can give the assignment to what the according to its atomic number. Higher atomic number will be numbered first. If your atomic number is more, for example bromine is there, chlorine is there, then first preference to bromine. Hydrogen, carbon is there, hydrogen is there, preference to carbon. So like that. Then least priority, that means 4th priority, it should be away from observer. Generally it is always away from the observer, that is at the 4th number. So and see the type of rotation. After assigning this 4 substituents according to atomic number, then look at the numbers, okay, and after that we can have what the rotation. So if it is a clockwise direction, so then we can substitute the what r, or the right side rotation is there, then substitute the r, and if you have what anti-clockwise direction, that is left side, then it is can be the s configuration. Okay, so this is the simple rule. We can identify quickly r and s of a particular carbon. But in some cases, if we are fourth priority, that is least priority, sometime it is an above the plane now, then what will happen? Then we can just reverse the configuration by default manner. Okay, if the fourth priority which is above the plane, then the configuration will be changed default, that is r configuration becomes s and s becomes a converts to what r. Okay, this is very simple and systematic way to explain the rs configuration. Okay, look at some example here. This example is given. So this is ethyl group, this is methyl group, and this is what the OH. So you know that so this is carbon, and this is oxygen. You know that oxygen is the highest atomic priority, so it should be 1. That's why in a red color mention the 1. After that methyl is having 1 carbon and hydrogens, while ethyl has 2 hydrogens and remaining carbon. So if carbon and carbons are same, then move to the another element. In methyl CH is there, in ethyl what carbon is there. So that's why the priority should be goes to one, second priority should be goes to the ethyl group, and third should be goes to one your methyl group, and last priority, that is hydrogen. Okay, least atomic number should be goes to last one. So now see the rotation now. So 1 2 3 4, how it will proceed now? So it is proceed like a clockwise direction. So if it is a clockwise direction, then should be a R. Okay, it is in rectus, and you know that the name of this compound is a R2-butanol. What is the name? It is an R2-butanol. Similarly, we can take the example of its isomer. Now we can have the S2-butanol. How one can find? So here again the same structure is given, but the position of OH and hydrogen is different. In first example, OH is above the plane, now here below the plane. Okay, likewise. So first priority should be goes to OH, second should be goes to ethyl, third should be goes to the methyl group, for fourth one will be goes to what? Hydrogen. So now see the rotation now. So how it will be proceed now? The rotation is what now? Again same, that is clockwise direction. But you know that fourth priority should be away from the observer. This is according to rule. So but here above the plane, then we can by default we can change the configuration. So that is what, if previously it is a clockwise direction, then it will be what? Anti-clockwise direction. So R will be converted to what? S. So this structure is called what? The S2-butanol. Okay, so this is very simple and interesting examples in many competitive exams. So they are asking about the R and S nomenclature. Find out. Okay, find out the R and S of the given compounds. The first try to find out the molecule. So try to find out the chiral carbon in a given molecule, and after that assign the carbon. Okay, like this. Now another question. Most of the students are very they are, that means it's unable to find out. Okay, most of the cases they are unable to find out what is homomer, what is enantiomers, and what is the distereomer. The homomers are nothing but the same, it's identical form. Okay, if you rotate 180, we can get the homomers. Now how one can identify the homomers, enantiomers, and distereomer with the help of this RS configuration? Now look at the first one. Now homomers are nothing but the, if two compounds are given, then first compound show R configuration, another also show the R, that is same carbon. Okay, so if you have compounds, okay, first find out the chiral carbon and find the RS. Okay, so if the chiral carbon is R and then another also show the R, then it will be homomer. RR are the homomer, SS are also the homomer. These are from two molecules. Okay, if two chiral centers are given, for example, if two chiral centers are given, so this one and this one, so if you are finding R and R for that, then we are again have what this one. So for example, this is R and this is R, so obviously it is an of same compound. Okay, it is an the homomers. Okay, likewise. So generally homomers also have the same type of configuration. What is enantiomers now? Enantiomers always have opposite, because they are mirror images of each other. We have right and left hand, they are not superimposable. That's why they show the different type of configuration. Now look at this one. So now if one compound show the R, its mirror image should be S. If S is given, then it should be a R. If more than one chiral centers are present, then what will happen? So for example, if you have two chiral center, and here also, if this chiral center show the R and S, then it should be S and R. So these two compounds must be mirror images of each other. Okay, that's why these are called to be enantiomer. Okay, like this. Now distereomers are obviously generally have two chiral center. Okay, and you know that. So if you find out the pair of a distereomer, then you will receive the out of 4 chiral center. For example, these are the 4 chiral center. So 3 are always same. or only one is different. Okay, or here, so look at this one, R, SR, in which 3 R are there. In the second compound, SS and RS, that means again 3S are there. So such kind of the compounds are said to be what, the diastereomer. So likewise we can quickly identify which one is homomer, which one is a enantiomers, which one is a diastereomers, like that. So if we given the 3 compound, for example 1, 2, 3, and they also mention the what, the RS configuration. Suppose this is RR, this is RS, and this is what, the SR, like this. Now we can simply identify what are the types of what are the activities there. So RR and RS, it should be 3 R are there, that means it is a diastereomer. If RS and SR are there, it should be enantiomer. So it should be enantiomer, it should be what, diastereomer. So what is the relationship between 1 and 3 now? So here look at this, RR, SR, so it should be again a diastereomer. So we can find, and in generally in compounds the pair of diastereomer are more than what, the simple enantiomers. So likewise, so we have so many examples, we can try to find out, try to apply your this concept on any molecule and try to find out the chiral center. Thank you for watching, stay connected, and if you satisfied with this, so don't forget to subscribe.